Hello students, welcome to my YouTube channel. Today I am going to solve the one problem, shear force and bending moment diagram for the simply supported beam. So this is the given diagram. So what is calculate the shear force and bending moment and draw the shear force diagram and bending moment diagram for a simply supported beam of 9 meter length, 6 meters UDL and 3 meters free height. UDL given carrying the UDL 10 km per meter for a distance of 6 meter from the left side. So sometimes suppose question they given diagram also you have to draw yourself and calculate the maximum bending moment diagram. So maximum bending moment will come when shear force will be 0. In that point maximum bending moment will come. So okay, what is the steps now? First we have to find the support reaction. First we have to find the support reaction. So we'll see the support reaction first. So we'll find the first support reaction. So solutions. Let's see the support reaction. Support reaction, how we are finding total upward force equal to downward force. We'll write in the equilibrium force. Summation of F equal to 0. Total vertical force equal to 0 means total upward force equal to total downward force. This always I am writing. So we are not taking sign conventions for that or not. So what is there here? RA plus RB is equal to load. Only UDL is there. So how much? 10 into 6. 10 kilonewton into 6 meters. So 10 kilonewton. Give equations number 1. Now we'll take the moment about A. Summation of total moment was 0. That means clockwise moment equal to anti-clockwise. Anti-clockwise, this concept we are following here. So here what is moment? About A point is fixed, so UDL will come first. 10 into 6 and 6 by 2 half distance equal to RB into 9. So how this coming? All the video I am explaining this. Suppose this you not understanding half distance why I am taking, convert this UDL into point load. Convert this UDL into point load. Suppose this is W kilonewton meter, this is length is L meter. Always I am discussing this. Draw the point load. So this due to the UDL, maximum deflections will be in like this. So maximum deflections in the middle. That means load acting in this point, middle point. Load acting in the middle point. Maximum deflections will be in middle. So load, what is load? W into L load. What is this distance? L by 2. So how we are taking this? 10 into 6. What is here? W into L by 2. So 10 into 6 into 6 by 2 middle distance. So that way we are taking this. Okay. So point load if you will convert UDL, so moment will be very simple. Point is fixed, load into perpendicular distance L by 2. Okay. This way, this all video I am explaining this. Okay. So now you substitute this RB, you will get here. This is 3. Okay. You don't cut, you will not able to read. So if you will see here RB is equal to value and RA is equal to value. If you substitute this, you will get RA and RB value directly. I am writing. That's okay. So RA will be RA coming 40, RB coming 20. RA coming 40 kilonewton. This is coming 20 kilonewton. So how much? 10 into 60. 40 plus 20, 60. So this should be add A, RA and RB should be 60. So it's correct only. Now we'll do the shear force diagram calculation. Shear force diagram calculation. So okay, so what is sign conventions we are following here? I will draw here. This is section. Downward force positive. This is called right side. Left side upward force will be positive. Then here reverse draw. Reverse will be negative. This is the left side. This is the right side. So now we will take in left side. Left side upward force will be positive. So this how much we got? RA we got 40. This we got 20 kilonewton is there. Okay. So what is the SAA? SAA, shear force, left side positive 40. Then this point you see A, B, C, take some point C. So what is the SC? Shear force at C. So 40 upward force positive. This is downward force negative. Downward force how much? 10 into 660. So this is coming minus, right here itself, minus 20 kilonewton. So you need also write kilonewton I wrote, okay. So shear force at C, you know, shear force at B, if you will go it will come, how much you see, shear force at B. So what is coming here? Total minus 20, and this is upward force. Upward force will be positive, plus 20 equal to 0. So shear force at B will be 0. Now we'll draw the shear force diagram. So C point, shear force diagram. First we'll draw the shear force zero line diagram. First we'll draw. This is the zero line. This is the zero line we are going to draw here. In this point, shear force will be 0. So first what is 40 kilonewton. So this is the draw there here. Solid line will draw. What is this one? 40 at point A. Now at point C, how much we are getting? 20. So somewhere here, join this line. If we'll join this line, like this will come. If scale will be good, so like this will come. Okay. So we can change here. So this is point A. So this is positive shear force diagram. This is negative. This is 20. Now, in between C and D, no load, so horizontal line. In between C and D, no load, so it will be the horizontal line will draw. Line will be horizontal. Then SB, again it will go 0. So this is the shear force diagram. Shear force diagram, okay. So this got. Now this point, you take some point A, B, C, D. In this point, shear force is 0. In point D, shear force will be 0. So maximum bending moment will come in this point only. Maximum bending moment will come in this point will only. So we'll see this calculation and we'll substitute this value. We draw this line so we can draw the bending moment diagram. So in this point, maximum bending moment will come. So D point shear force 0. So bending moment diagram calculation. So always bending moment diagram will draw MA will come 0 equal to MB. This will come 0 only. Bending moment diagram will come both in 0 because we take moment over to a no right side force. If we take this side, no perpendicular distance for this particular RA and RB. So both will come 0. So we'll take the bending moment at C. Bending moment at C. So that sign conventions also write first. What is this is? Clockwise, negative. Anti-clockwise, negative. If we'll take reverse, this is clockwise, this is ACW. This side will come plus. This is the section. This is anti-clockwise. Then this is clockwise, positive. So we are taking, this is right section, this is left side. So we are taking left side. So bending moment at C. So left side, what is this going clockwise? Left side clockwise, what is positive? So what will come? 40 into C distance 6. Now this coming anti-clockwise, left side anti-clockwise, negative. See this anti-clockwise, negative. This point C, force going clockwise, this coming anti-clockwise. What is that? 10 into 6. This is the load. And what is half distance? Into 6 by 2. So this is the bending moment at C. So how much coming here? So 240 minus how much here? 10 60 दिया 90. So how much is coming? We'll see the bending moment at C. Bending moment at C is coming 240 minus 10 60 60 18 180. This is come 180. See here 10 into 6 into 3 10 60 60 18 180 180. So 240 minus 180, how much we got it? 60 kilonewton meter. So we know the year 60 kilonewton meter. So blindly don't calculate everything. So always you just check it. So 243 3 na 60 into 3 180. So bending moment at C we know the how much? 60 kilonewton. Now we have to calculate the maximum bending moment diagram. So suppose, because distance we don't know, take this distance is x meter. Take this distance is x meter and take this triangle here out. So we'll get the value for this. So triangle is like this. So this is this distance is 40. This is 20. This we taken x. This will be 6 minus x. So see here, this taken x. Total is 6. So this distance will be 6 minus x. So I draw it here. So how we'll calculate this? We'll see the x by 40 is equal to 6 minus x by 20. So how much will come? This will come here 2. So it will come here 40 is 2. So x equal to 12 minus 2x. 2x will come here 3x equal to 12. So x equal to 4 meter. So that x equal to 4 meter we know. So x bending moment at 4 meter. How much we'll get? So what you do now, before you find mx. So take one sections here somewhere. mx now some sections you'll take now. What will be there here? 40 into x minus 10 into x. Don't write like this. 10 into x into x. You write here 10 into x by 2. So if we'll substitute x equal to 4, m4. So what will come? m4. 40 into 4 minus 10 into 4 by 2. So 160 minus 40 दूना 80 80. 2 get cancelled. 10 40 दूना 80. So it will come 80 kilonewton meter. So that means bending moment will be maximum bending moment. So we can write here maximum bending moment is 80 kilonewton meter. 80 kilonewton meter. Now we'll draw the diagram. So now we can draw the diagrams. Okay. So we know the maximum bending moment 80 kilonewton meter. So we'll draw the diagrams now. Okay. So what is there? UDL. UDL means shear force diagram will be inclined line. Now here what is there? UDL. UDL means bending moment diagram. For UDL, bending moment will be parabola. So now you draw here. First maximum bending moment will be, so zero line first you draw. Zero moment, this is bending moment diagram will be, bending moment will be 0 in this line. So B and A, bending moment will be 0. Now we are drawing for the maximum bending moment. So how much you take here? Curve line. So this is nothing but 80 kilonewton meter. Now here will be curve line only, but this how much? 60 kilonewton meter. Now here inclined line, because no load, so this will be inclined line you draw here. inclined line. So this is the bending moment diagram. This is the bending moment diagram for this. So look here, bending moment A and B will be 0 because no force that side, no distance, force into distance not there. If you will calculate also, it will come 0 only. By the calculations, unnecessary will not go like this calculation. So MC we calculated. Got 60, this point 60. But they're asking what is the maximum, calculate the maximum bending moment. So at where the shear force will be 0, bending moment will be maximum. That is objective question also. If shear force will be 0, bending moment will be maximum in this point. So for this, we don't know the x distance this. So we assume this is x distance. So this is the method to calculate the x. So x by 40, 6 minus x by 20. So we got the x equal to 4, this distance. So this point is 4 meter. Now if you substitute, take the moment for the x section xx. Somewhere we taken section xx. So this taken xx section. So takes 40 into x. Then this distance x, 10 into x by 2. So substitute here x equal to 4. So x equal to 4, now we got the maximum bending moment and we draw the diagram. This is the way we can solve the simply supported beam, shear force and bending moment diagram and calculation and maximum bending moment. Okay, students, thank you. Watch this video, share this video to your friends and subscribe the channels. We are doing the hard work for you peoples only. So subscribe the channel and share the video as possible as. Okay, thank you.